了解比较好。然后我是台湾的那个 Google Developer Expert，那主要就是帮忙宣传 Google 的技术。那我们今天很荣幸邀请到 Google 新加坡的云端中心的一个非常重要的工程师卡蒂格来帮我们演讲。那卡蒂格是在新加坡的 Google， 那主要是负责 Google 云端，就是 Google 它的 App Engine、Computer Engine 跟 BigQuery 这些项目。那他对这个方面非常了解，可能是整个亚洲最了解的人。所以如果说大家有任何的问题，都可以非常把握这难得的机会去跟卡蒂格做一个交流的把握这个机会去跟卡蒂格交流。那我们时间就，我先把时间交给卡蒂。
Do I really need the mic, or can you hear me without the mic?
Where's the mic?
Not a good idea. All right. Let's do the mic then. Thank you very much, and thank you to the Docker Group for inviting us here today. Thank you very much for that. My name is Karthik. I'm based out of Singapore. I work for Google Cloud Platform, and I work with all of the large customers of Google, helping them make their transition to the cloud. Before today's topic is going to look at containers. That's why we're all here, and how containers and the Google Cloud Platform really work together. And we're going to do some demos, and let's keep it interactive. Talk anytime, ask me questions. Happy to answer any questions that you might have. But before we get started, how many of you actually heard of the Google Cloud Platform? Not bad. It's much better than the last time because, I've been doing this for almost a year now, right? So every iteration I see more and more people know what the Google Cloud Platform is and so on. Maybe I'll just give you a brief introduction as to what the Google Cloud Platform really is all about. And then we can go ahead and actually talk about containers and how they marry with the Google Cloud Platform. My talk will take roughly about 60 minutes plus in total. So, and then we can have as much time as you want for question and answers afterwards. So, Google, as you know, is been building easily what would easily be the world's largest and highest quality cloud infrastructure on the planet, right? Because that's what Google has to do to be successful as a company. Whether that's our Gmail product stack, our YouTube product stack, or the search product stack, which made everything possible for us, we've had to constantly keep building infrastructure which is highly efficient, highly scalable, and extremely fault resistant to make our own services highly available. Right? If you look at Gmail, it's probably one of the few services which doesn't have a stated downtime. If Gmail goes down, that's headline news, right? Because from the get-go, we don't have the opportunity for any of our services to go down. If search goes down, I always joke with my wife, Google.com is where you go to figure out if the internet is working, right? So that's the level of resiliency our services have to provide, and to do that, we have to have a really high-quality cloud infrastructure. And that's what we've been doing for 15 years. And we were doing cloud before the term became a marketing expression, which I don't know what it means these days. But what we're doing with the cloud platform is taking that same infrastructure, services, and engineering that Google has done, and exposing it to you as a service through RESTful APIs that you can use to build any application that you want. Right? So the same stuff that makes Google Google is now being exposed to you to write your applications and have them deployed and run on the same kind of infrastructure that Google households run. If you look at this diagram here, this is one, I love this picture, but it's one bar of one data center that Google has. And every one of those lights down there is a rack. Right? So you can multiply by the X, the Y, and the Z, and you can understand how much capacity there is. Right? And recently, in April, I don't know how many of you were following the news, but we launched a data center in Taiwan as well. Right? And you can basically build and deploy applications which are geo-resident in Taiwan if you choose to do so as well. And towards the end of this talk, hopefully you'll stick around for that long, I will give you a coupon code which allows you to have $500 worth of credits for you to go and play and build your own applications on top of the Google Cloud as well. I'm not bribing you to stay. If you have other things to do, that's fine too. So when I say we expose those services to the external world, we expose those services in 3 different buckets, right? So there's a compute bucket, there's a storage bucket, and there's a high-level app services bucket, right? Notice that we don't talk about infrastructure and platform, etc., because we like to think of things in these kind of blocks, and we don't think that the infrastructure and the platform distinction is of that much value. We have put in new features in the product which basically dissolve that kind of a disparity. But on the compute side, we have 2 different products. One is App Engine, the other is Compute Engine. Right? So App Engine is what you would typically call as a platform as a service, and Compute Engine is what you would call as infrastructure as a service. Right? And as of today, both of these actually support Docker. Right? So for Compute Engine, we have Docker optimized VM images, and for App Engine, we actually allow you to do, deploy Docker images on managed virtual machines as well. So both of those are actually supporting Docker as of today. So that's good news for this group, right? And whether you choose platform and infrastructure, you could blend those 2 services in any way, shape, or form, because we allow you to do something that we call as a managed virtual machine. So in a platform as a service, basically you bring your app logic, which is your code, and your data, and Google manages everything else for you, right? But in that environment, in typically platform as a service infrastructure, you're not allowed to bring in arbitrary binaries and such. So if you wanted to do arbitrary binary execution, you would normally drop into infrastructure as a service, but then there's a huge drop because you lose a lot of the management that comes with platform as a service. So what on Google we do is blend those 2 together, and you can have VMs running part of your PaaS application if you like, and those VMs can all be Docker images as well, right? So you take good advantage of both the scalability that comes and the management that comes from platform as a service, and blend it along with the infrastructure if you choose. You could also go full-blown infrastructure as a service, right? And that's our Compute Engine offering. And the nice bit about Compute Engine is that these are all running on top of Google's global distributed fiber network, right? So we run easily what is the world's largest open flow network. So if I opened up a project in Google, and I put one Compute Engine node in, say, Taiwan, one Compute Engine node in Europe, one Compute Engine node in the US, without doing anything, those 3 are already a virtual network. So I can, and all of the traffic that goes between those nodes never go on the public internet, they just ride on Google's fiber. So you can get very consistent latency between a node, say, that's in the US, and a node that's, say, in Europe, and a node that's, say, in Taiwan. And that allows you to create newer application architectures that you couldn't do before, right? So you could think of the world as a distributed grid where you drop these nodes everywhere, and you build distributed topologies riding on top of Google's investment in fiber, right? So I have customers who actually exploit that a lot. So they have distributed data sets which span the globe, but they keep themselves in synchronization, taking advantage of the fact that Google provides that networking from the ground up, right? Then you have storage, which is cloud storage, Cloud SQL, and Cloud Data Store. So we need to store data for our applications, obviously. So Cloud Data Store is our NoSQL storage offering. So this is the same storage offering that backs up App Engine, right? And it does anywhere about something like 6 to 7 trillion data store operations every month. Right? That's not a billion, that's not a million, it's a trillion. So that's the scale. Those are the same NoSQL clusters that we use, and that's just being exposed as a service that you can use in your application. Cloud SQL is basically managed MySQL instances, right? So it speaks like MySQL, it behaves like MySQL. We even support the MySQL wire protocol. So you can go ahead and just spin up a relational database and just not worry about high availability clustering, failure across zones. All of those just come automatically for you. And finally, we have cloud storage, which is basically our object-based storage, object storage model. We can store up to 5 terabytes an object, unlimited number of objects, and we again take care of replication across various zones, etc. So that's for object storage, relational storage, and a NoSQL storage. Now all of these are stuff that we use internally as well. So for example, cloud storage is basically the same kind of infrastructure that backs up YouTube, right? So all of these have been battle tested at the scale of 1 billion people, right? And now we're just turning them loose to you to take advantage of the whole thing. And the last two one are basically BigQuery and Cloud Endpoints. Cloud Endpoints is basically at a PaaS level, which is App Engine, where you can write your backend code for your backend server for your application. Would that be a mobile application on Android, a mobile application on iOS, or a JavaScript web phrase frontend? You write that code once, and then we take that code and automatically generate client libraries for iOS, Android, and JavaScript. And that just makes the whole process of creating multi-client capable application that much easier. And finally, it's BigQuery. BigQuery is basically, how many have heard of Dremel? A couple of you. So if you want to look at how some of these things work under the cover, just go to research.google.com. Right? What we do is to build these things, put them in production for a while, and once they're stable, we actually write a research paper telling the world what we did. So if you read the Dremel paper, BigQuery is basically Dremel as a service. So what is that? Basically, it's Google's own big data analytics tool exposed as a service. So you can bring your data in row column format, CSV or JSON, and just ingest that data. Once that data is inside BigQuery, you can start writing SQL queries against it, SQL-like queries against it, and not have to think about any infrastructure. So you can go from data to insight pretty fast. I think our biggest customer for this is the National Health Systems in the UK. They have a data set which is like 800 plus terabytes in size. And they ask questions against it, which previously they could not even do. And BigQuery returns those answers in like a minute and 30 seconds. Right? So it's a fun tool, it's very cheap too. So go ahead and play with that. And so that's the whole stack, right? So I'm not going to cover the rest of the stuff today. I'm just going to focus primarily on Compute Engine, and then we're going to talk about how Docker works with Compute Engine as well. Right? So I'm assuming everybody here is completely familiar